We're going to talk about the domain and the range given the graph of a function, and what you want to keep in mind is that the domain is all the permissible x's, all the x's that you might have used in your function, and the range represents all the y's that could pop out. So you really want to think about that domain as being on the x-axis, because it's all the possible x's, and the range as being on the y-axis, because it's all the possible y values that could happen. One thing that is helpful to keep in mind if you think you might get these two words confused is that domain comes before range in the alphabet and x comes before y in the alphabet. So if you're worried about keeping those things straight, that's a little tip that's helpful. But to actually look at the graph, what I'm going to do is I'm going to trace this graph. And by trace, I mean literally just trace it the way I'm tracing it right now. And when I'm considering the domain, I want to think about all the x values it might be hitting. So what I want to do is this motion that I'm making with my pencil right now is think about how that would look if I was just doing it on the x-axis. And if I were just doing this on the x-axis, it would kind of go as far over as this point, and then if I were to trace it over here, as far over as that point. And then of course all these x's in between. It's very helpful, I think, to translate this down or smoosh this graph onto the x-axis to see what's going on. And I want to write an inequality that represents this. So I clearly have all the x's that are between -4 and 6. So to write that algebraically, I'll put the lower number here and the higher number here. I will literally put x in between them. And the -4 is the smallest, so the alligator would not eat the -4. But it would definitely want to eat the 6. That's going to be my domain. All the x's that are more than -4, or -4 is the smallest thing we have, and 6 is the largest. For the range, I'm going to do a similar thing. I'm going to trace, 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 but I'm not thinking about up and down. I'm sorry, I'm not thinking about left and right. I am thinking about up and down, up and down. What's the highest point I hit? What's the lowest point I hit? And I'm going to translate that over to the y-axis. So this is my highest point, would be here. And I'm going to go low, 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 low. I start going back up. So this is my lowest point here. It goes over here. And as I look at this, clearly my y values are between -3 and +2. So -3, 2, it's a range, so it's a y value. And the -3 is the smallest thing, and the 2 is the largest. So it's going to look just like that. All these are going to be similar things, but I'm still going to talk through it. So for this graph domain, I'm going to go left, I'm going to trace, I'm going to think left, right, left, right, left, right. So this is as far left as I can go. So that would be here on the x-axis. I can go to the right forever, 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 and this arrow indicates continue on forever. So it'd be all of this stuff. It has a definite beginning point, and then all the x's go this way. We saw that as I traced towards the right, I could go to the right, and I could just keep going to the right forever. So I have a low point, but not a high point. So I would use x and -5 as my expression, and all of these x's, of course, are these bigger than -5 or are these less than -5? And if you're not sure, think of an actual number over here. Like over here, I've got the number 1. Is 1 bigger than -5 or is it less than -5? And clearly 1 is bigger. So the arrow is going to go this way. If you're the kind of person who struggles with knowing how to draw the arrow, but you know there's a 1 over here, imagine like that little 1 sitting over here. And if you had the statement 1 and -5, and if you know it goes like this, that could help you figure out the way to draw the arrow, correctly. Just a little advice. Anytime you're looking at an algebraic expression and you're not sure what to do with it, pick a number that you know works and work with the number instead. It's easier to think about sometimes. As far as the range is concerned, same idea, up, down, up, down. So as I go up, 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 I can go as high as this point right here. I'm going to translate that over to the y-axis, because we're talking about the range. And as I go down, 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 down forever. Down forever and ever and ever and ever and ever and ever and ever. So its range, it's y. That endpoint is at 6. And I need to decide if these numbers are bigger than 6 or if they're less than 6. I hope it's clear to you that these are all less than 6. But if it's not obvious to you, pick any one of these points and consider its y value. Like for instance here, the y value is -3. -3 is less than 6, it'd be less than that. That'll be my range. Moving along to this graph, left, right, I can go left, looks like forever. I can go right, it looks like forever. So if I were to put that on the x-axis, it'd be right, left, and right forever. So that's all real numbers. That's how I can denote that. As I go up, I can go up forever, I can go down forever. So again, all real numbers from my range as well. Good luck.